Material traceability is crucial. These billets are destined for Process A, while the fluid is reserved for Process B.
A laser measurement system rapidly scans the external dimensions of the billet, projecting fine red grid lines. The vast, organized factory shows two conveyor systems. A robotic handling unit places an aluminum billet onto
Thermal sensors verify the MLPRF 83282 fluid stabilization. This critical
The industrial diamond cutting tool shaves off metal from the 775-26 billet at high speed.
As the current flows, a durable layer of chrome is applied. Chemical handlers meticulously monitor the solution to
The XRRF spectrometer precisely measures the chrome layer in real time. The digital readout
The piston rod undergoes magnetic particle inspection, coated with fluorescent particles. The massive piston rod, designated Process A, is transferred for stabilization. Logistics per
The inventory manager confirms the quality clearance status. The data instantly updates the central system, signifying
briefing. A logistics technician attaches the standardized manifest, detailing the material history and quality checkpoints. The specialized robotic forklift moves the massive piston rod assembly towards the transfer airlock.
Environmental stabilization confirmed. The airlock allows transfer to the sterile assembly area for the hydraulic fill, monitored by precision sensors.
The automated borescope camera microscopically examines the internal surfaces, confirming absolute cleanliness.
The flawless dimensional conformity is evident as the critical sealing mechanisms engage.
This final structural closure for Process A integration in massive shock up
The decay rate is stable.
Confirmed. Zero leakage detected. Structural validation passed. A final visual inspection confirms that Process A is 100% complete, finalized, and ready for
The gauge drops instantly, achieving a near-perfect vacuum. This critical step in Process B prevents cavity.
Pressure stabilizing at nominal. De-aeration complete.
Confirmed. Logging Process B success.
Sensor alignment looks good. Ready for the pressure test.
Confirmed. Pressure approaching maximum load.
The damping coefficient is within tolerance.
Confirmed. The extension curve looks good.
Following thermal cycling, the external seals around the piston rod are meticulously inspected using a specialized helium mass spectrometer leak detector.
Uniformity is excellent across the structure.
Readings confirm the polymerization is complete.
The pressurization results are well within tolerance.
Confirmed. Coating integrity check passed on all points. Centering looks good on my side.
Confirmed. Let's get the lid on.
This device allows us to monitor the environmental integrity throughout the journey, ensuring full traceability for this critical component.
Power up the rollers now. Copy that. Keep guiding it in. We are clear for the ramp.
Okay, the absorber is clear. Verify part number and serial.
Verified. PN 10022, serial QTR B001. Caps are secure.
Alignment confirmed on the display.
Engaging the locks now. Pressure stable.
Sequence complete. Process B finalized.
Bring it down slowly. We need precise alignment on the forward lug.
Moving it now. Clear on the left side.
Looks good. I have the pin ready. Bring it up to spec. Holding steady at the limit. Confirmed. Pressure holding steady at max load.
Articulation is smooth.
The F-15EX demonstrates its capability, validating the structural integrity of the landing gear under extreme stress.
The precise metering of the golden amber hydraulic fluid ensures a stable and safe rollout, confirming the
Aircraft is fully mission capable, ready for immediate refuel.
The culmination of the production pipeline rests on this single critical component, the fully integrated and charged